The results of machine learning model can be analyzed in terms of bias and variance. Our aim is to have a model with low variance as well as low bias. Since this can never be achieved, we accept the trade-off between the two, that is bias and variance. This figure I have taken from this interesting article. The source is this. The first figure shows a regression line which is straight and with very low variance. And the last part of figure shows a regression curve with high variance. And the last part with high variance have a low bias. And this has a high bias. So this is a kind of the middle figure is a kind of a trade-off between the two. And this can be taken as best fitted situation. So this is overfitting, and the first one is underfitting. The training error here is bias, and generalization error here is variance. So error of the model can be divided into variance and bias as well as irreducible error. So error of the model is equal to variance of the model plus bias of the model plus irreducible error. The bias tells us about how closely the model captured the mapping function between input and output. The bias is always positive. A high bias can cause a model to miss the relevant relations between feature and target outputs, that is underfitting. Some of the algorithms are more prone to low bias and some of the algorithms are prone to high bias. So the low bias algorithms include decision tree and k nearest neighbor algorithm, especially with the when we have different number of neighbors. And the high bias algorithm include linear regression and logistic regression. The variance tells us about the amount of performance of the model when it encounters an unseen data. A high variance may result from modeling the random noise in the training data, that is overfitting. And the algorithms which are prone for high variance include decision tree and k nearest neighbor, especially with less number of neighbors. And low variance algorithm include linear regression and logistic regression. This is a figure I have taken from this source of internet. The less complex the model complexity is along x-axis, the less complex model have high bias and low variance because they are almost like a straight line or something like that. And models which are very complex, they have high variance but they have low bias. And the total error, so we settle at a trade-off between the two when both are the lower. So this is the optimal model complexity. This I have taken a example Python codes to decompose the error into bias and variance. So first of all, let us make a fake data using make regression library of sklearn. Then we split the data into train and test set using this library, and we will be using k neighbor regressor. And for decomposition, I will use bias variance decomp of ml extend library. So this is the implementation. First part of the code is k neighbor regressor using number of neighbors equal to 1. The second part is k neighbors regressor with number of neighbors 10. So we will see what effect on error is when number of neighbors are changed. So this is the result. So when the number of neighbors are 1, we have a bias of 1773 and variance of 965. Whereas when number of neighbors are 10, we have a variance of 312 as compared to 965 in first situation, and the bias is higher as compared to first situation. So when the number of neighbors are equal to 1, we have low bias and high variance. when the number of neighbors is equal to 10, we have high bias and low variance. So this is more generalized model as compared to this model. And so this is how we decompose the mean square error of the regression into bias and variance using the library ML extend. So this is all for today. Thank you very much.